This video is for section 14-1 about synthetic substitution. This is a skill that you use with polynomials, and that's what chapter 14 is about. Often scientists and engineers must find values of some function to a specified accuracy. This can be accomplished with polynomial functions because it's always possible to achieve the desired accuracy by using a polynomial of sufficiently high degree. Remember from the earlier chapter about polynomials that degree refers to the exponents. The higher the exponent in a polynomial function, the more closely it can fit a situation when you model. Functions whose values are given by equations such as f of x equals the square root of 2x plus 1, or g of x equals 2x squared plus x minus 3, or h of x equals x cubed minus 8, are called polynomial functions. You've learned about these in an earlier chapter this year. This one goes to the first power, it's linear. This one goes to the second power, it's quadratic. This one here goes to the third power. I don't remember if we had a word for that, but that's cubic. We know how to evaluate functions by direct substitution. For instance, if you wanted to find f of 3, you would substitute a 3 where the x is, and then figure out what this is equal to. That's called evaluating the function. Direct substitution is when you take the value that you want to put in for x and actually substitute that in for x. There is another way to evaluate a function, and that's called synthetic substitution. And this is a process to be learned. And here are the steps of that process. With synthetic substitution, you write out the coefficients of the polynomial in order of descending powers. Then you write the number to be substituted to the left. Make what's called a synthetic substitution bracket. And then you go through the process, which is a multiplying and adding process. The remainder that you get is the value of the function. Now let's make sense of those 4 steps by trying an example. Polynomial q of x is right here. Its highest degree is 4. It also has a third power term. It has no x squared term. It has an x term, and it has a constant term. We want to find q of 2, but with synthetic substitution. So the first step of the process is to write down the coefficients of all the terms. 2, then negative 3, then 0, then 2, then negative 1. Look where these numbers are coming from. Here's the 2. Here's the negative 3. There's no x squared term, so there's 0 in as a placeholder. It's kind of like having 0x squared. And then here's the 2, and then here's the negative 1. Next, write the synthetic division bracket. It looks like this. So it's kind of like a long division symbol, but upside down. Next step, take the number to be substituted and write it to the left of the bracket. So we're going to substitute a 2. You write it over here on the left side of our bracket. Now we're going to follow through the process, which is still on the top of the screen here, step 3. Pull down the first number. So take that 2 and write it underneath the bracket. Then do a multiply and add process. 2 multiplied to 2 makes 4, and you write that under the next number. Now add these together. That makes positive 1. Now do multiply and add again. So 1 multiplied by the 2 makes 2, and then you add these together, and that makes 2. Now what do you do? What do you do with this number and this number out front? You multiply them and write the result under the next number. What do you do with these two numbers? You add them. Now what? 6 multiplied to 2 makes 12. Now what? You add these numbers together, creating 11. The very last number that you get underneath the bracket is called the remainder. And as it says in step 4, the remainder is the value of the function. So q of 2 is equal to 11. Do you believe it? Here's how you figured out Q of 2 in the past. You would substitute 2 where the x is. So every place where there's an x, we would fill in 2. And then work this out in our heads or on a calculator. 2 to the 4th is 16. 2 times 16 is 32. 2 to the 3rd is 8. 3 times 8 is 24. Right here, 2 times 2 is 4. 32, take away 24 is 8. And 8 plus 4 is 12. And 12 minus 1 is 11. Same answer. Now what's going to be faster? Synthetic substitution or regular direct substitution? Everybody's opinion is going to vary on this. Right now you're more comfortable with this because you've never done synthetic substitution before. But when you practice this one enough times, maybe you'll end up liking that method better. Here's another example. We have function f, and it's given right here. And we want to figure out what is f of negative 2i. Now instead of putting negative 2i in place of y every time, let's try the synthetic substitution. Write down the coefficients. 2, negative 5, 5, negative 20, and negative 12. We don't need any zero placeholders because it never skips a term as it counts down to the constant number. Then make the bracket. Take the number to be substituted and write it on the left side. Now we're going to follow through the process, which begins by dropping this one straight down underneath. Then multiply these together. 2 times negative 2i is negative 4i. Now add these. It makes negative 5 minus 4i. Now multiply this to the negative 2i. So negative 5 times negative 2i is positive 10i. Negative 4i times negative 2i is positive 8i squared. But I squared is negative 1, so 8 times negative 1 is negative 8. Then add these together. So this is 10i minus 3. Now multiply the 10i minus 3 to the negative 2i. 10i times negative 2i is negative 20i squared. But I squared is negative 1, so negative 20 times negative 1 is positive 20. Negative 3 times negative 2i is positive 6i. And then add these together. And those 20s are going to cancel out. So this just makes 6i. Now multiply 6i times negative 2i. And that's negative 12i squared. But I squared is negative 1, so negative 12 times negative 1 is positive 12. Then add these together, and it makes the answer 0. That last number is the remainder, and that's the answer for when we substitute negative 2i. Next example. If r of x is equal to this polynomial, find the value of m so that r of negative 1 is equal to 4. Let's do synthetic substitution again. Write down the coefficients in the correct order. Make sure you don't need any placeholder zeros. Then make the synthetic bracket and take the number to be substituted and write it on the left side. Now the fact that this says equals to 4, what does that tell us? It tells us that this very last result is 4. Now let's run through the process. What do you do first? Pull down that first number. Then multiply these together and write the result underneath. Now what do you do with these? Add them. So we get m minus 2. Then multiply. So m times negative 1 is negative m, and negative 2 times negative 1 is positive 2. Then add these. The negative 2 and positive 2 cancel away, so you're left with negative m. Then multiply negative m times the negative 1, and that makes positive m. And then what do you do with these two numbers? You add them, and apparently it turns out to be 4. So 3 plus m, I guess, is 4. So what's m? And we discover that m equals 1. Let's summarize the lesson. We're going back to working with polynomials, which are the type of math expressions that you have the most experience with this year. You've done a lot of work with linear polynomials and a lot of work with quadratics. That's where you were factoring, doing quadratic formula, graphing parabolas, and all of that. You don't have as much experience with polynomials with a higher degree, like to the 3rd power, 4th power, 5th power. One of the skills that you can do with polynomials is evaluate them by inputting different values for x. And in this lesson, we learned an alternative way to evaluate called synthetic substitution.